Hello, this is Alexander Monks and Eric Pack, and this is our CS2316 final project for Group 100. Now, this is our table of contents, what we will be running through. And for our purpose and interest, for our topic summary, we are scrutinizing whether food-desert correlations can direct further investigation to influence policy and action to best address societal deficiencies and improve outcomes. We want to expect negative outcomes associated with individuals living in food deserts. Specifically for food deserts, we expect positive correlations with obesity and life expectancy, and negative correlations with poverty, median income, and education. Now here's our summary sentence, and by looking into food deserts, income, life expectancy, and education data, we can explore the correlations between variables throughout the United States. Exploring this data can once again help identify areas of need that can shape future policy or investment initiatives to best target inequalities. Specifically, food deserts are places of residency that lack accessible sources of nutrition, often forcing individuals to consume foods with potentially adverse health effects. And with these findings, we hope to possibly make a change. Now for our data collection process, first with finding data, we check government websites through the databases provided, and we quickly found sizes of the data files to ensure that they were large enough. From there, we made sure that the files were sorted by counties, which we'll explain later.
Yeah, and for our first downloaded data set, which we got from the USDA, the data included the percent of households in food deserts sorted by the census tract, and it also included a lot of other data such as the poverty rate and the median family income, and so it had a lot of extraneous information which we will get to later.
And now for our web requirement 1, which was our web scrape data, we retrieved it from the data.gov database provided, and most importantly, it had the percent of individuals with high school and college diploma by state. Again, this was sorted by counties, and later on we discovered that it couldn't be web scraped, but we didn't discover this until the cleaning stage. And now for our web requirement number 2, which was the API file, it was retrieved from the same database, and most importantly, it had the data of life expectancy in years by county. Again, sorted by counties, and the data was stored as a JSON file, but it was treated as an API file during the cleaning process.
And then finally, for our additional data set, it was also downloaded and it was retrieved from data.gov database, and it was only for Georgia, but it was the obesity percentage sorted by county, and it had many years ranging from 2004 to 2021. And then for our data cleaning process for our downloaded data set 1, we had the USDA food, and so initially the information was sorted by census tract, while all of our other data sets did not have this information. Instead, it was sorted by county, and so we needed a way to transform the data to also be in counties. And so we needed to take the averages within those counties, multiply them by the population, and then from that we could get the county population to get the overall averages within those counties to have the same amount of data. So we had to transform the data quite a bit, and then there was a lot of extraneous information. There were 147 rows in total, and so we had to remove a lot of those data columns, and ultimately gave us the end result.
And now for our web scrape data, again, as mentioned before, we realized that this was a government website and we couldn't clean it. So Selenium was needed to bypass certain JavaScript walls put in place to prevent access to the data, and was recommended to find a new database by TAs. I still attempted Selenium, but I ran into too many errors with too little time left. And so we ended up just finding a wiki table, and it also was used as an alternative and represented education rates. We used Beautiful Soup to parse through it, and we removed columns in a row that for some reason had a Canadian province, and we just reformatted it as well. Now for the API file, we used pandas, and we used the typical request.get to read the JSON file as an API. We dropped 3 columns and we specified it using the axis equal 1. And most importantly, I think we split the county column on comma delimiter to remove state abbreviation from the values. And we did this for consistency with the other files.
And then for an additional data set for Georgia, it had data from 2004 to 2021, but so we only used 2019, so we got that using masking because it matched the data time frame of our other data sets, and we replaced the description within the urban column, which had like non-urban counties, and we replaced that with 0 and 1s to represent the counties, and we also changed the state abbreviation in Georgia to remain consistent as well.
And then, so we did all this with the state names and the counties so that we could combine these tables. And we combined tables 1, 3, and 4 with using the .merge function, and we joined it on the county and state columns, and we specified how using the inner function to get an inner join. And now for our data analysis, insights, and visuals, we're going to go into Insight 1 and Visualization 1. For our insight, we wanted to see the mean data of all counties within each state and comparing the food desert percentage and life expectancy. To the top right is where our code and the table provided is. And for our visualization now, we can see that states with high percentages of households in food deserts often have lower life expectancies. This can be seen in the right here with the two maps of the US, where the southeast is a lower life expectancy compared to the northwest. And here's our code again, showing our visualization. And for Insight 2 and Visualization 2, for our insight, we wanted to look at only at urban counties to see whether a correlation exists between food deserts and median household income. This generated a correlation coefficient of negative 0.23, which was a weak negative correlation that shows as income tends to increase within counties, the percentage of households that live in food deserts within that county tends to decrease. And again, the code and table is shown to the right. And for our visualization, household median income negatively correlates with the percentage of households in a food desert by urban county, which is also shown by the right here with a scatter plot.
And then we wanted to show the influences on academic outcomes and see whether food deserts had a strong correlation, but we only saw a weak negative correlation, which means as the food desert rate goes up, we see some drop in academic outcomes, but it was not that significant. But we did see a positive correlation with life expectancy and a negative correlation with poverty, and so those were more meaningful. And on Insight 4, we saw within Georgia, we wanted to compare the food desert percentages of the 20 most obese counties and the 20 least obese counties, and we saw a really unexpected result. As the percentage of counties in as the percentage of food deserts in counties increased, the obesity decreased, which is really bucked expectations, and so it led to further investigation, which goes on to Insight 5. And so because we were so puzzled by the findings of Insight 4, we wanted to look at the correlation of obesity with our primary variables, and we saw a negative correlation of 0.4 with the food deserts, and we saw a weak positive correlation between obesity and income, which is also unexpected, and then no correlation with life expectancy, which is also really unexpected. And so this might be due to Georgia's unique demographics, but regardless, it's definitely worth looking into more. So we were surprised by this, that we double checked like our whole process and our data just to make sure we had what we think we had. And then moving on to the conclusions, we were expecting really adverse correlations with food deserts, but we really didn't see anything beyond weak correlations, especially as evidenced by the obesity percentage, which actually went down as food desert percentage went up within Georgia. And ultimately, this project highlighted CS2316's effectiveness. With the foundation from the class, we could integrate new functions like the correlation core pandas function to expand our abilities and potential impact.
And once again, as stated before, we had a lot of difficulty with Selenium, and then having to find another data set that was not sorted by counties like the rest of the files was very inconvenient. And it took a little time deciding on the best way to implement and compare it with the rest of the data sets. Below here is pictures of our attempt at Selenium, but eventually we just decided to just scrap that and find another data set and compare the other data sets by state. Thank you. We hope you enjoyed our presentation.